In this tutorial, we have got question 4 from the DBE, the June exam paper, paper 2, 2023. The question is based on organic molecules, and this is specifically with regards to the reactions of organic molecules. Reactions like dehydrohalogenation, dehalogenation, hydrogenation, and so on. So this is question 4. Let's get into the question 4.1.1. The question reads as follows. The flow diagram below shows different organic reactions. P, Q, and R are organic compounds. So we are given this flow diagram here. Okay, we have got P, alcohol P, compound Q, and the reactions given as illustrated here. And then we are given that the reaction 1 is an addition reaction. So here reaction 1 is an addition, and we see that there is a Br2, which is a bromine, that is being added. So write down the type of addition reaction that we have here, 4.1. So we are taking compound Q and we add, since we are told that it's an addition reaction, so we add Br2, which is bromine, and this is the product that we get. So when we are adding bromine, this is a halogen, so the reaction is called halogenation. So the answer to that is halogenation. That is halogenation. So we are adding bromine, which is one of the halogens. 4.12, write down the one observable change which occurs in the container during the reaction. So one observable reaction that we'll find here, we are reacting bromine with an alkene. How do I know that this is an alkene? Because with addition reaction, we only add to an unsaturated hydrocarbon. So this should have a double bond, and then those two other bonds, then they are filled in by Br2. So one observable reaction is when we react bromine with an alkene, the bromine is actually decolorized. So to answer that question 412, we can say that 412, the reddish brown color of the bromine is decolorized. Okay, that is, the solution becomes colorless. The solution becomes colorless. Okay, so it is decolorized, or the solution becomes colorless. Naturally, bromine is reddish brown in color, so it becomes colorless when it reacts with an alkene. So that's the observation that we see here. 413, write down the structural formulae of compound Q. Write down the structural formula of compound Q. For us to get the structural formula of compound Q, we must get a clue from this, the product that we form here. Okay, when we add bromine, we get 1,2 dibromomethylpropane. So this one should tell us the compound Q. So to explain this one before we get to write the answer, let me explain to see. Let's take out this one. Let us write this down. 1,2 dibromo 2-methylpropane. Right. What we have here is a propane. So I'll write propane is 1, 2, 3. Okay. And we are told that at carbon number 2, we've got a methyl. So at carbon number 2, I must have a methyl. Okay, methyl is C with 3H. Okay, so that is a 2-methyl. And then at carbon number 1, we've got a bromo. And at carbon number 2, we've also have a bromo. So we've got a 1,2 dibromo. So I'm going to add a bromo here. And we are going to add a bromo there. Okay, and then the rest we have single bonds. Since it is a propane is an alkane with the single bonds all over, single bonds between the carbon atoms. So which means this is the structural formula of the product. Now, which means before we added the bromo, here, how did the structure look like? Okay, how did the compound look like? That's what we are trying to find out. What is the structural formula of compound Q? So to get the structural formula of compound Q, we can simply cancel out the bromo here. If we cancel the bromo, so we will have two bonds that are open. And from the study of organic chemicals or molecules, we will find that these two bonds will constitute one bond added here. Okay, so that this bond now will combine to that one, that bond will combine to that one. So to give the final answer to that one, we are going to get a formula which is C. This C will have 2H. Okay, we have an H there and an H there. And here we are going to have a double bond because now our Br were not there initially. Remember, this is the structural formula for the product 1,2 dibromo 2-methyl propane that we are illustrating here. So we are sort of working backward from the product to get the reactant. And so here, this C here, coming back to the answer, this is C, we have one C here, okay, with a methyl branch, and then there will be a C again with 3H there. So meaning that this will be our final answer to that, okay, which is a methyl. If we were to give it a name, this is a methyl prop 1-in, okay, or a methyl propene, because there's no prop 1-in, so we can just call it a methyl propene. So that's the structural formula, the answer that they want from there. Okay. Then, so we have written the structural formula of compound Q, and then consider reaction 2. So we are now on reaction 2. So reaction 2 is we are taking the compound Q and reacting it and HCl, reacting it with hydrochloric acid, and we are getting compound R. So we are required to write down the IUPAC name of compound R. The IUPAC name of compound R. Now here, 4.14. With 4.14, we are required to find the compound R. Now, compound R is we have reacted our alkene here, which is the methyl propene that we have here, because this is our compound Q. We already know that. Now, when we react it with HCl, so what will be our product here? Okay, let me explain again by using the structural formula how we can get compound R. So what we have here is we have got this compound here. I'll write it again here. That is a C with double bond here to another C, double bond there. And then this is a C, there's a methyl there. And we have got a C there with 3H. Now, when we react it with HCl, hydrochloric acid. Now what will happen to this is what we want to see. Okay, so what will happen, it is a double bond, so we are going to break this double bond here. So when we break the double bond, we will have a situation where this is a C, so this will give us arrow, this will give us the product C, okay, with an H here and an H there, because there are two H, and then this one now is broken into one bond, so it will be one C, one bond there to another carbon, which is and this carbon is also bonded to C with 3H there, okay, and this one is C with that 3H. So what happens in a reaction, in an addition reaction, is we are breaking the double bonds between the carbon atoms into single bonds. Now you will notice that the first two C's now, they have got open, they have got incomplete number of bonds here. There's 1, 2, 3 and 1, 2, 3. So each one has got 3, which means that carbon must have 4 covalent bonds, a maximum of 4 covalent bonds. So here, which means we need a empty bond. I will indicate it with that red color there, and here there is an empty bond. So when we break the double bond, it creates 2 extra bonds, empty bonds. Okay, now those empty bonds are the ones that are going to be filled by H and Cl. So H will go to this bond here, and Cl will go to that bond over here. Now there's a rule that applies here, because there's an option that Cl can come on the first carbon and then H, but the major product, according to Markovnikov's rule, it says that the major product is formed by the addition of the hydrogen atom to the C atom or the carbon atom that already has got the most number of atoms, and then the halogen atom will be added to the carbon atom that has got the most alkyl substituents, meaning that when the H, there's an option to add an H and a Cl, the H will go to the C that has got the most number of H, okay, and the halogen will go to the carbon that has got the most number of the most alkyl substituents. When we say alkyl substituent, this C has got a branch here. This is an alkyl. That's why we call it a methyl. And this C also has got a branch here, a substituent, and this C so this C has got most number of alkyl branches. So which means the halogen will come here. So this product will be our major product. So to answer question 4.14, this will be our answer here. Okay, so we can write it down as 414. What is our product? It will be C with an H here, H there, H there, and then C, this is C here, with the chloro, that C will take a chloro, and there is a methyl branch here, that one will still remain, H, 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 and then there will be a C here that has got 3H. Okay, so that will be the final answer. The structural formula, they want the IUPAC name of the compound. So this is wrong here. So the IUPAC name is, so we'll delete this one out. They want the IUPAC name. So the IUPAC name is the systematic name for this one. So as you can see here, the IUPAC name is 1. We have got 2 branches. we've got a branch, we've got a chloro here. I'll just go back to the same answer that we have derived here. We've got a chloro, and then there's a methyl branch. Okay, in a chain of C's, 3 C's. So this is a propane. Okay, this is a propane, but in that propane, we've got a branch at chloro. We start alphabetically. Okay, so we start with a chloro, then we go to a methyl. So our answer will be carbon number 2. I've got a chloro dash at carbon number 2 again. I've got a methyl. I've got a methyl in a chain, in a propane. Okay, because we've got the single bonds there. So our IUPAC name for that compound R, the one that we get here, the IUPAC name is, as we have explained here, 2-chloro 2-methyl propane. Okay, so that gives the answer to that part of the question. And then we have got question reaction. For reaction 3, write down a balanced equation using structural formulae for the organic compounds. Okay, write down a balanced equation using the structural formulae for the organic compounds. Okay, let me just copy this question here. Okay, so let's take it and create more space here now. So we are on question 4.15. For reaction 3, so we are given reaction 3 over here. Okay, and this is our reaction 3. Write down a balanced equation using structural formulae for the organic compounds. So in reaction 3, what we notice is we have got a compound R, which we have just found here. It's a good thing that we got the structural formula here. We have already derived the structural formula over here. Okay. So they want us to find the structural formula to write a balanced equation using structural formulae for the organic compounds. So what we see here is we have got this 2-bromo 2-methyl propane, and we are reacting it to give us an alcohol. Okay, we are given an alcohol. So what clue do we get from here? So we have got an alkane that is being turned into an alcohol. So you'll find that reaction is a substitution reaction, or we call it hydrolysis, because we are making an alcohol. Okay. So if we were to write down that compound Q, like, okay, the question that we have here, a balanced equation using structural formulae. So 4.15. Okay, we can take it as, let's just take our product R, because that's what we are reacting, our 2-bromo 2-methyl propane. Okay, this is our BR here, and then this is our methyl there. And then we've got this. Okay, so this is our product R, as we have already determined earlier. So now, for us to get an alcohol, what could have happened here? an alcohol has got a functional group which is an OH, which means there's an OH here. So what will have happened for us to get an alcohol? It means we now have substituted this bromine here. We have removed the bromine and we have added a hydroxyl there. So for us to add that hydroxyl, we are going to react this with another compound, which is sodium hydroxide. So we'll get a sodium hydroxide. So the sodium hydroxide will react with this. Okay, and what are we going to get after that? So what we'll get is the sodium hydroxide. Since I mentioned earlier that it's a substitution reaction, the sodium hydroxide will substitute the Br, and the Br will be combined to Na. So what we'll get now, the major product is going to be C, which means this C here, 1, 2, 3, okay, bonded to this C, but the Br will be substituted, so there we will have an OH, and here we still have our methyl over here, and then this is bonded to C, that, and that. Okay, so this is our structural formula plus sodium hydroxide. We'll get this. But to balance of the equation, since they said the balance equation, remember the Na is there. So here the Na and the Br are going to bond together. There's an ionic compound here, which is sodium bromide. So that will complete our structural formula, our balanced structural formula. We've got 6 marks for that. And then for the same reaction 3, we are required to write down the IUPAC name of alcohol P. So what will be this alcohol? Okay, what is the name for that? So 4, 1, 6. So again, it's a propanol. But as you know from the nomenclature of naming hydrocarbons, our propanol, we have to indicate where is our hydroxyl, because hydroxyl is the functional group. So this is a propan 2, because our hydroxyl is carbon number 2. But again, we have got a methyl branch. So this is going to be at carbon number 2, we have got a methyl. And this methyl is in a propan 2-ol. So you've got a 2-methyl propan 2-ol. That is our the name for that particular alcohol. Okay. Then reaction 4 is an elimination reaction. Write down the type of elimination reaction. Write down the type of elimination reaction that takes place. 4.17. Okay, so here in reaction 4 we have got this one over here. Okay, so it's an elimination. So we are taking this alcohol, which is our 2-methyl propan 2, and we are going to eliminate. Now when we eliminate this, we'll come back to that compound Q that we got earlier. Okay, so now what we have, remember what we had earlier, the compound Q, we said it is a compound that is like this. Remember, they asked us to find the structural formula of compound Q. So we have got a double bond there. So if we were to write down the elimination, okay, what are we going to eliminate? So basically you will see that if we come here, we have got an alcohol. We have this alcohol, okay, and we have this H here, which means literally we have removed the alcohol and we removed the H so that we could have a double bond there. Okay, so remember, when we remove or when we eliminate two atoms, the double bond must be formed between the two carbon atoms from which the atoms were eliminated. So we will eliminate the hydroxyl, okay, and we eliminate the hydrogen. So we'll be back to our compound where we've got a double bond there, our methyl propene that we got earlier. So when we eliminate OH and H, okay, since we are told it's an elimination, so what is the type of elimination we have here? So this is water, H and OH. So that is a dehydration. So the reaction is a dehydration because we are eliminating water. We have removed water from the alcohol and then we'll get our alkene. Right. So that answers that part. And then we are told that 4,2 butane 1 or reacts with the propanoic acid in the presence of a catalyst, and write down the type of reaction that takes place. So write down the type of reaction that takes place. Okay, this one, butane 1, is an alcohol. This is alcohol. And propanoic acid is a carboxylic acid. That is a carboxylic acid. So you'll be aware that when we react an alcohol plus a carboxylic acid, the homologous series that we get here is an ester. So it will happen in the presence of a catalyst. That catalyst is sulfuric acid. So we react alcohol plus carboxylic acid, we get an ester. So what is the type of reaction that takes place here? The type of reaction, we are producing an ester, so we call it esterification. So 4,2,1, the answer to 4,2,1 is esterification. Okay, so that is esterification. Right. Then write down the IUPAC name of the organic compound formed. The IUPAC name of the organic compound formed. So the IUPAC name that we get here is, remember, we are reacting an alcohol. Okay, we are reacting an alcohol here and a carboxylic acid. So the IUPAC name of an ester is made up of two parts. The alcohol will give us the first name. Okay, in this case, our alcohol is butanol. So we will get the name will be a butyl. Okay, the first part of the name is a butyl from the alcohol, which is the butanol. Okay, the second part, second part of the name for an ester is a carboxylic acid, and our carboxylic acid is a propanoic acid. So it will, the name will be a propanoid. It will be a propanoid. So it's a butyl propanoid. Now the function of the sulfuric acid is to remove the water. Okay, is to remove the water. Maybe let me just explain what will happen here. So we will have our butanol, which is 1, 2, 3, 4. Okay, so we'll take it like that one. That is a butanol, and our alcohol is on carbon number 1. So I will take this one to be the alcohol. So this is alcohol, and then we'll react it with propanoic acid. So propanoic acid is okay, I'll take C double bond O, I'll write the OH here. Okay, let me just write it nicely. Okay, so we have our C, so we react plus C with an O and H. I'm deliberately writing the COOH on this side here, and a C and a C. Okay, so that's what we have here. So what will happen from there? What will happen from there? So when we react it, so the water that we are talking about here that will be removed is this section over here. Okay, is that section. So we will have the OH and the H from there, and then in the end we are going to have a compound of this type, which is a C, 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 C. Okay. So that part is the butyl part, okay, bonded to this O here that was in our carboxylic acid with a C double bond O and other C's there. Okay, there's another C over here. So was it a propanol? So the propanol would then be a propanoate. So that will be our C with H and H. Okay. So we've got two parts to the question: butyl. You can see a butyl branch here and a propanoate. Actually, the name for an ester, you can read more, is divided. You can divide it here along this O here, this oxygen. So it's got two parts. This is a propanol, a propanoate from the propanoic acid. This is a butanoate, a butyl rather, from the butanol alcohol. So to answer that question, where the full name is a butyl propanoate. Okay, so that answers that question 4.22. I hope you learned something. Please remember to subscribe as well and share the video, and also pass your comments, anything that you wanna comment on or share or add, and then we'll be able to interact on the platform. Thank you and goodbye.